Hello everyone, this is Joe Neville. How's it going? I'm back with another Aruba AOS-CX basics video. So in the last video we had a look at layer 2 configuration, essentially VLANs, and in this video we're going to move up the OSI stack and have a look at layer 3 config. Now there's two approaches to configuring layer 3 interfaces on AOS-CX. The first we're going to look at is where we create the VLAN and then we create a VLAN interface and place the IP address against that. And the second approach is where we put the layer 3 configuration directly on the port natively, so no VLAN at all. Let's have a look at that first approach then. So this is the interface VLAN approach. Here's my network diagram. So it's very similar to the network that we set up for VLANs in my previous video. You will note, well, the eagle-eyed will notice that I've updated the Windows client. I've swapped it out for a new Ubuntu 19.10 because I love playing around with new OSs. So I wanted to have a look at that, but that shouldn't affect what we're doing here. So in this setup, we have two nodes, both in the same subnet. We have the VLAN 150, which is switched between Aruba 8320-1 and 8320-2. So this device over here, 101, can ping over here 102 when everything's set up correctly. Now, if we wanted to move that to a layer 3 setup, now one of the things about this configuration is that the Aruba devices are only acting as switches, so just layer 2 at the moment. They don't have an IP address in this 192.168.150 range. But with the interface VLAN command, we can allow the Aruba devices here to participate in this VLAN and still switch the traffic for the Ubuntu servers. We do that with this configuration. So we have to have the VLAN on the boxes, and then we create an interface VLAN and we add the IP addresses on there, and that allows the switches to participate, as I say, in this broadcast domain, and we can give them IP addresses like 103 and 104. So that's what we're going to do first. And at that point, 101, if all's configured correctly, 101 will be able to ping 102, but would also be able to ping 103 and 104 as well. So it's a combination of layer 3 and layer 2 switching. Let's have a look at that second approach then. So this is where we have the layer 3 dedicated port. So this is quite different from the first approach and actually changes the nature of our network design. What we're going to do is we're going to take these ports that connect between the two CX devices, so 1/1/1, we're going to change their state from a layer 2 port to a dedicated layer 3 port. We do that by entering the interface subcommand here, so we can alter from layer 2 to layer 3 by entering the command routing, and that at that point, as a layer 3 interface, we can configure the IP address and the v6 address directly on the port. Now, the thing about that is that now there's no VLAN 150 flowing across here. So we've essentially broken this broadcast domain. As you can see, right, so no VLAN 150, so we've broken the end-to-end layer 2 between our Ubuntu clients. Now, 101 won't be able to ping 102, so we need to do a redesign. Essentially, the 8320s have become our layer 3 gateways, and that means that we need new subnets. For example, what we could have in this setup is, and this is just one of many different approaches that you could take, I've opted to leave VLAN 150 here as for this segment, and then added a new VLAN of 151 between the CX devices and renumbered them, and then added in a new VLAN here for 152 between this CX box and the Ubuntu 19.10 client here. Okay, timeout. Sorry for the interruption, but I made a mistake there when I said that I'd created a new VLAN. I meant a new subnet. There's no VLAN running across that link between the two CX devices. There's just a new subnet. Okay, sorry about that. On with the video. That also means I need to do the addressing, and also over here we need to, so essentially the Ubuntu client, I've left this one with its original IP address, but we do need to add a new IP address in there. And then people that are thinking ahead will realize that actually now, because we've broken the broadcast domain between the two clients, just setting it up like this means that we're not going to have end-to-end connectivity here. So what we would need is some way of this device here knowing about this layer 3 segment over here. So that is static routes or routing protocols. Okay, but that's getting ahead of ourselves. We're just going to set up the basic configuration to show you. First of all, we are going to focus on the interface VLAN then. So let's jump over to the demo and set this first approach up. Here's my demo setup then, very similar to the last video. I've got my 8320-1 top left, 8320-2 top right. I've got my Ubuntu server that I'm going to send my traffic from so we can test the end-to-end flow, bottom left, and then I've got Wireshark. The 8320-2 is mirroring its port that's connected to -1 to my Mac, and I'm running Wireshark on my Mac. So essentially down in this bottom right window we will see the traffic as it hits this 8320. Okay, so I've rolled the config back slightly from the last video for people that haven't watched that one. If you haven't watched it, why not? So here we have essentially the setup is that the 1/1/2 connects to the Ubuntu server. So this is where the traffic will come in, and then we need to ship it across this 1/1/1 that connects off to the 8320-2. Okay, now as you can see, I've taken off the VLAN and I've reverted it back to a layer 3 interface. So let's get on with the configuration then. So I go conf, we need the VLAN first. Then I will go into, let's do it that way, go into the interface. So it is no routing, no shut. We want VLAN trunk allowed. Let's just have 150. So if we do a do show run int. Okay, so that is my interface set up to switch the VLAN 150. Now let's put on the layer 3 interface. This is the new stuff. So interface VLAN 150. It's as simple as that. So this is creating the logical layer 3 interface. And on there, we can put the IP address directly on it. So it's going to be, I just picked another interface, not particularly good addressing, you might say. But it works for this demo. Okay, TB8, so it's 150, and we'll just give it the same. Like I said, that's not how you would address a well-designed network, but that will do for this demo. Right, so if we do a show run, you will see that we have, first of all, the VLAN on there, then we have the interface now configured to allow that VLAN to flow across, and we have our layer 3 interface in that VLAN, so we are participating in that. So if everything's working, let's come out of here, we should be able to ping 150.103. Now that's up. Okay, so we can ping ourselves. Good, we didn't have to no shut that or anything, and we should be able to ping up to 150, so it's 101 it is. Okay, yes, and we can ping. So that is essentially me pinging the Ubuntu, the connected Ubuntu server. So from the Ubuntu, it would be 150.103. There we are, we're pinging our 8320. So now we're not just participating at layer 3 and switching the traffic, we're actually now a layer 3 node on the network that we can ping. We can route off of that subnet if we had other subnets configured, and we can switch the traffic. So let's jump over to the 8320-2 and do essentially the same thing. I'll show you what this looks like. Okay, we've got the mirroring fine. This is the interface that we want to concentrate on. I've added the VLAN in there because the connected interface off to the other server is in access 150, so I needed that VLAN on here already. Okay, that's by the by. So let us go. So we could create our VLAN interface straight away. IP address 192.168.150.104/24. v6 address will be db8 150 184/64. Good. Okay. And then it is now for us to no routing, VLAN trunk allowed. Always recommend that you use both ends of a link should be set the same to avoid any kind of confusion. Okay, so that's good. Actually, I didn't show you. So if we do a show interface 1/1/1, you'll see that it. We've got to no shut that. It was good that I checked that. Okay, so let's no shut that. What I wanted to show you is essentially this stays as a layer 2 interface. Shut. Okay, good. Save that. So come out of here. Show interface. This stays as a layer 2 interface. Good. But now we have the show VLAN interface 150. Alright, so one without the space. Okay, so this is now our layer 3 interface, okay, which is admin up. We have our IP address on there. What's the show IPv6 interface? 150. Okay, so for the layer 3, it's show IPv6 interface 150. And you can see that we've got our v6 address on there. Okay, great. Now, what that means is that I should, from the further point, I should be able to ping a bit further through the network then. If everything is set up, I should be able to ping 104, which I can do. So that's pinging from here, switch through this -1 out to -2. Just to recap, we're pinging from 101 through 103 into 104. So this is all now set up and successful. The final ping that I need to do to get the end-to-end is 101 to 102. Okay, back to our demo then. I did notice that when I did the ping, we weren't receiving any traffic. So I've just done a bit of troubleshooting of the mirror session. I've edited it out because it's not relevant really to the subject of the video. Essentially, I hadn't enabled the mirroring session. So the mirroring session looks like this now, okay? And when we do the ping, essentially all I really want to show you is the fact that the traffic is coming in with the VLAN. So 104, we are successful. We are hitting this CX devices interface with a VLAN of 150. There we are. Okay, because we're running across the trunk. Okay, right, let's cancel that. The final ping to go end to end is actually the one that we were originally doing in the first video, which is 102, and there you can see the traffic is flowing end to end. We have the ping response, so we know that we've got two-way communication. It's hitting the H320-2's interface with the VLAN 150. So this is good. We can ping and participate in this subnet. 3 and 4. Okay, brilliant. Right, so we have our node set up for the first approach. Now, the second approach, as I mentioned, somewhat different because we're going to break that end-to-end connectivity by transitioning these ports to layer 3 without the VLAN being switched through them. So let's get on with that. So we will show run interface. These are the ports that we need to change. So show run. This is what we're going to do. So factory default is that it's routing. So it's a layer 3 port by default with CX. Let's do that first. Go into here. I'll shut it down if I can type. And we will go routing. So that will show it. Okay, now we are a layer 3 port. So it's admin down, like I said, but you can see L3 counters there. We don't have a trunk or an access statement anymore. This is what it now looks like. Okay, so you don't see the routing command because that's the default. And in this state, we can put our IP address directly on the interface. Now, the thing is, because this essentially, I'll jump back to the diagram so you can see. To do this means readdressing our setup. So I'm going to use a different subnet. I'm going to use a /30 there, 151 as the third octet. Leave the original Ubuntu server as 101 and then move this link here into a different subnet. So we'll go, it's 151.1, I'll go /30. One 64. Okay, now on the other end, okay, I'll leave that one shut down so we don't shut this one down. Routing IP address 51.2/30 IPv6 address. Okay, no shut. Good. Okay, so at this point, there's no point pinging from here. We're not going to be able to ping across to this guy. Let's see if we can ping across our connected link. And I should mention, actually, that all of this is in the default VRF. So show VRF. We only have, I've only got, so that the out-of-band port is in the management VRF, and all of the front panel ports, other than the management port, all of the in-band ports are put into a default VRF unless you create a new VRF and place it into it. So by default, everything goes in the default VRF. And when you do a ping, for example, it defaults to the default VRF. So you don't have to put the specific VRF if you do a ping. So let's try to ping ourselves. Good, as you'd expect. And let's try to ping the other end. Looks like moving the port dropped it out of the mirroring session, so I've just added that back in. Oh, okay, fine. And now we can see it. Right, so the traffic's coming in, and as you will notice, there's no VLAN on this. We don't attach a VLAN tag to a standard layer 3 interface. So there's the successful ping, there's the traffic, and you can see no VLAN. If you wanted to have multiple VLANs flowing across this connected link, you would have to use a layer 2 interface for 1/1/1 and then use the interface VLAN, and then you'd be able to send multiple VLANs and layer 3 traffic separated via the VLAN tag across this link. But for the layer 3 interface, it's just one layer 3 subnet, no VLAN. Okay, I think that's as far as I'm going to go with this video. Otherwise, we get into a situation where I need to start reconfiguring the different subnets, the different VLANs, etc. And then it still wouldn't be able to ping, as I've mentioned before. We would have to have some routing or some static routes. And that's kind of getting off of the topic of just focusing on those different interface types. So in these last two videos, what I've shown you is the layer 2 state where you can have an access port, or you can have a trunk and allow different VLANs on there. Or you can have a layer 3 dedicated interface that doesn't switch VLANs across it. If you want to switch multiple VLANs across a link like this, your option would be to go for keeping this as layer 2, so have a trunk there, and then have multiple VLAN interfaces at layer 3. I'm trying to keep each one of these videos quite short and to the point, though, rather than with these basics. It would be quite easy to kind of get off topic and just start showing everything and start turning on OSPF and all those good things. We'll try to divide this up into neat packages and keep the running time down if I can. Right, so thanks very much for watching. Please do leave comments, like, subscribe, dislike, all of those good things. It all helps to work out what the audience is interested in. And if you've got any comments, I've had some comments so far, a little bit off topic about some of the stuff that I was planning to do, but it kind of gives me an indication of what people are interested in. My plan, the roadmap for this video series is to focus on the layer 2, the layer 3, and then I really want to get deeper into the layer 3, looking at OSPF. If anyone's watched my old BGP in-depth videos in the past, I really want to kind of recreate some of that stuff using OSPF, using BGP, to kind of go to that depth. Okay, so that's the plan. It's all about time, whether I'm able to get these videos recorded. Okay, enough about that though. Thank you very much for watching. My name is Joe Neville, and goodbye.